Okay, and this is calibration for both wheels at a time to make sure that they're in somewhat synchronization, that they're running towards the same speed. So all we do in this program is run them for about 10 seconds, and what we're doing is we're taking a look at, and we have our wheels with the little blue lines on there, and we're just making sure that they keep in sync with each other. So if I can turn them on, what we're trying to do is we're trying to verify that these stay in sync with each other. And when we start and stop, that they pretty much stay in sync. And they do, and so we think we'll go straight. So that's our calibration for going straight. Very important part of this. Okay, here's our calibration program for turning it. And what we have is we just go and we make right hand turn, right hand turn, right hand turn, right hand turn. We go straight for a while in between each turn. But we're trying to get it calibrated so it makes the turn at 90 degrees. Now what we have are two factors. Right now they're both at 1, but one will change our normal turn delay and we can alter that, and the other one will change the factor that we're giving the motors themselves to account for any differences in torque or whatnot. So we'll see how that works. And here's the right turn calibration program, and all we're trying to do is have it make nominally pretty good 90-degree right turns. And let's see what happens. And those are pretty nominal 90-degree turns, so we can adjust the fudge factor as we need to. Okay, this is just a picture of the code for turning left, and we're going to do the same calibration we did for turning right to turn left. So we'll go straight, turn left, straight, turn left, straight, turn left, and hopefully we get 360 degrees or fairly close to 90-degree turns. Okay, and here we're going to run the turn left and see how we go with 90-degree turns. And again, we're just trying to get them in the ballpark. So let's see how we do. And that looked pretty good. So we'll use that and see how it works in the maze. Okay, here we are with our little obstacle course, and here's a view of the obstacle course, and we're going to try to get our little robot vehicle to maneuver through it. And I'll start up our vehicle in a second and see how he does. Okay, here's our cart maneuvering through the maze, and he's going through. Going up the ramp, down the ramp, and headed towards the finish line unscathed. And there's our maze. Okay, now for our maze, what we're going to do is we're going to have a semi open loop, closed loop system. It's kind of passive closed loop because we run it until we hit a limit switch, and then we go in reverse, and then we steer it around. So what we have is a program that this is the simple first iteration where we just run forward and until our limit switch is engaged, and then we run in reverse, and then we stop. Now the other thing is we're going to use an LCD VEX display on these things. And so now what we have, if we look at our cart, is we've got our LCD display up on top, and we've got our limit switch up on the front of the cart. And we run it until we hit the limit switch, and then we go in reverse. And in a minute, we'll take a look at how the very first iteration of this goes. Okay, in our first iteration, we're going to run the robot on the table, and we're going to move him into our toolbox. You should stop and then reverse for 1 second and then come to a complete stop. And I'm going to try to focus in on our little digital display so that we can see what happens. I'm going to hit our reset button so the program resets. And there we're going forward. Okay, reverse and stop. And now we're about ready to try it on our maze. Okay, and here's our program for going through the maze. Now the only thing that we did is based on our calibrations for the turning factors, we put in a couple fudge factors for especially the right hand turn. We made it a 0.9 instead of 1, and then we adjusted our turn delay for our left hand turn since he was making really severe left hand turns. So that's what we're going to use when we're going to run through our maze. And when we get to the finish line, we'll say we're at the finish line when we finally stop. And let's see how it works. Okay, here's our robot through the maze, and we're going to reset them and see what happens. And here we are, right at the finish line. Okay, when we were running, you couldn't really see the display. We couldn't keep pace with it. So what we're going to do is reset our thing. We have it tilted off the table, and we're going to reset the code. It says iRobot, like the Alan Parsons, goes forward until I hit the limit switch. We go reverse, return, and we go forward again until I hit the limit switch once again. Reverse, now it turns right, forward, till we hit the limit switch once more. Reverses, turns, forward until we get to the finish line. And there we have it. That's what the display does while it's running.